Now, feature engineering in healthcare. So feature engineering is where the magic happens in healthcare AI, and it is also where your clinical expertise becomes most valuable. Feature engineering is the process of creating new variables from existing data to help AI models make better predictions. Now, it's like having raw ingredients and combining them in ways that make something more useful than the sum of their parts. I'm going to give you an example. In healthcare, we do this all the time, even if we don't call it feature engineering. When you calculate a BMI from height and weight, that's feature engineering. When you use creatinine and urine output to assess kidney function, that is feature engineering. When you combine heart rate, blood pressure, and vasopressor requirements to assess hemodynamic stability, that, my friends, is feature engineering. Now, the difference is that in AI, we can do this systematically across hundreds of variables and millions of patients. We can create features that capture complex clinical relationships that might be difficult for humans to track consistently on their own, being a human. For example, an AI system might create a hemodynamic instability index. This combines, let's say, for example, mean arterial pressure, heart rate, the vasopressor dose, and fluid balance in a way that predicts ICU outcomes better than any of these variables alone. And so let's say a mean blood pressure may be a variable that predicts ICU outcomes, but it is not as good when you combine it with heart rate, vasopressor dose, fluid balance. So individual variables may not be as good as all of these variables combined. Dear all, I hope you are doing great and that you are liking these lessons and you are enjoying and you are learning. And I did want to suggest something as an option for you. Only if you are one of those who want to have this content in a more organized manner, there is a program that I have set up that you can find in the description. It absolutely is not necessary. However, it is only for those who do thrive in an organized approach, and there just might be a few more goodies there as well. Anyways, I wanted to share this, and now back to the video. Feature engineering might also help out in trends and monitoring trends. It might create features that capture trends over time, not just that a patient's lactate level is now, but how quickly it is rising and whether it is responding to treatment. And this is where the Holy Grail comes in, that it can assess over time, it can see what interventions are working, and it can analyze how to address that concern. Now, the key insight is that good feature engineering requires clinical knowledge, and you can't create meaningful clinical features without understanding the underlying physiology and the pathophysiology. That's where you, as the clinician, as the subject matter expert, and the human in the loop comes into this picture. And that is why healthcare AI development is most successful when it is a collaboration between data scientists and clinicians. The data scientists can look at all the data they want, but they still need you. So the data scientists bring technical expertise in machine learning, but the clinicians bring the domain knowledge that makes the features clinically meaningful. Now, when you are evaluating AI tools for your clinical setting, ask about the features that the model uses. Do they make clinical sense to you? Were clinicians involved in developing them? Can you understand why the model makes a prediction it does? Meaning that you can explain the results that the system is producing. So you being the human in the loop, you need to learn much of this, and that's what we're here for in this program. Now, to recap feature engineering in healthcare. Let me get the red back because I like red. Feature engineering is where the magic happens in healthcare AI. It is the process for creating new variables from existing data to improve clinical performance. Basically, designing your own models and metrics and performance indicators. For example, BMI is a feature variable. It's from height and weight measurements. And you can get an AKI score from creatinine and urinary output. And you can have a hemodynamic instability index from mean arterial pressure, heart rate, and vasopressor use. Independently, they are good. But combined, they can lead to a new feature that is more representative. And you can create models that people have done in the past, and you could have your name published. You could have your name published. Great. Wouldn't that be? And good feature engineering requires domain expertise. This is where healthcare professionals add tremendous value in AI development. And you have the feature engineering process is raw data, you transform it, new features, better AI. Now, this is a bit more technical, but we will leave this for now. And this is a process. There's some data acquisition, signal processing, feature engineering. Of course, that helps out with the diagnosis if you want, or if you want prognosis for that particular AI.